I'm bringing it up for the people who are watching the video. I'm bringing it up. You won't be able to see this. I'm bringing it up on here and see if I can figure out what it's called, because the name just escapes me at the moment. Trend line. It's called a trend line. Okay? But a trend line and a line of best fit are the same thing. This one happens to be a straight line, so it's a linear trend line. Okay? So you must have a line or curve of best fit. Okay? Also called a trend line. Okay? Must have that. Got it? Everybody understand? Alright. Now, you need to have grid lines. I know what grid lines are, right? Must have grid lines. Equally spaced grid lines. Okay? And these grid lines, if you're using Microsoft Excel, and we will use it a lot in here, will be both major and minor. So if you look on the spreadsheet that I have in your document, that I've already put in everybody's box, let's go back and find that. Here's one, okay? See kind of how some of the lines are a little bit darker than others. The slightly darker ones are major grid lines. The slightly lighter ones are minor grid lines. Okay? And what that does is it allows the viewer to figure out where those dots fit. It's not just a general thing, it's more specific. We're in the sciences, we want to be more specific. That clear to everybody? Any questions? Alright. Now then, you have to have axes labels. Okay? The axes have to tell me what's being plotted on that axis. And it must include measurement units. And those measurement units, just like on the tables, in the column labels must be in parentheses. Okay? The only time you don't have a unit of measurement in parentheses is when it's a counting number you're plotting for some reason. Okay, you usually don't need any kind of measurement units in parentheses when you have a counting number. If you're counting stuff, okay, if it's a population number, there's no reason to have units of measurement. All right, we don't do that very much in chemistry, but just in case just so you know. Now, the axes must be numerically labeled. Okay, the axes must be numerically labeled. So there'll be these little tick marks along the edge somewhere, and this might say 5, and this will say 10, and 15, and 20, and 25, or whatever. Equally spaced, labeled number lines. Okay? Equally spaced, labeled number lines. Axes format. Equally spaced, numerically numbered, huh? Yeah, it shouldn't be open, but I have another teacher who walks through here, has to get through there, and they don't really follow my rules too well. I'll have to put a sign on the door and say leave this door closed or something. Just to keep people from coming through the lab area and getting hurt on something. Let's see, numerically numbered number lines. Okay. Let's see. Axes descriptions with measurement units. In parentheses. All right. Got all that? All right. Then, if you remember, the tables had to have a table number and description at the top. Graphs are not labeled at the top. Well, they're labeled in the sense the title's there, but the description isn't at the top. The description is down below, and it's called a figure. It's numbered like tables. The first figure is 1. The second figure is 2. Okay? All right, so let's talk about the figure formats. Okay. Word figure, capitalized. Followed by number and period, just like the table number. Okay? That's the figure number. Now, in the table label, you had to tell me two things: what's in the table and why it's important. Okay? Figure labels have those things as well, but have one more thing. So, the figure description tells me what is being graphed, and you want to be specific, not general. Okay? What is being graphed, why it's important to compare, because that's what a graph does. It compares, looks for a pattern in sets of data. Okay? Why it's important to compare data sets. And 3, and this is the one that students will have the hardest time probably, well, should have. These others are pretty straightforward, generally speaking. Okay? Sometimes students work a little bit trying to grasp, well, what is being specific enough, you know? But this is a term that you need to know. It's very specific to science. It's very important to science, and that's called the analysis. Students have a hard time understanding the difference between an analysis and a broader type of conclusion. There are lots of different types of conclusions. An analysis is a kind of conclusion. Okay, we had an inference was a conclusion based on your observations, right? You kind of reached beyond the observations and said those observations mean this. That's what an inference was. That was a kind of conclusion. You have a conclusion that you might put at the end of a report in which you kind of wrap up everything. Okay? This conclusion, the analysis conclusion, is more limited in kind of like the inference is limited. The inference is limited strictly to what you observe. Okay? It can only go just to what you observe. The analysis only goes to what you're comparing here and the pattern you get from that best fit line of curve. Okay? So if I were to have this kind of best fit line, my analysis would be that whatever I've measured down here on the x-axis has a linear positive relationship with whatever's on the y-axis. Okay? That's called a direct relationship. Alright? So if it has this pattern right here, that's a direct relationship between however I describe the x-axis data, whatever I'm measuring down there, and whatever I measure on the y-axis. Okay? Does that make sense? If I were comparing force and acceleration, y'all remember that from physical science? Force and acceleration. Okay, I'd find a linear relationship between force and acceleration. And I would say, in my analysis, the pattern of data that we acquired shows that there is a direct relationship with the force applied to our object on the acceleration that results. That makes sense? So it's highly related to the title, because the title's also telling you how we compare this to this. Right? But it's going beyond what the title. Title only says we're going to compare it. The analysis tells you how it is compared, how this pattern shows you it's compared. Does that make sense? Yes? It what?
It's not busted, basically.
Oh, well, go take care of it. Sure. Go dry it out, whatever you need to do. Okay? All right, so the analysis. So the analysis is how the independent variable data or measurements, let's say data because sometimes independent variable or dependent variable are actually calculations and not measurements. Like yesterday, our lab, the final thing we put on there was the density. Well, that was calculated, not measured. We took two measurements and we calculated to get a density, right? Okay? So sometimes, that's why I say data. All right? How the independent variable data compares to the dependent variable data and what pattern can be seen. Okay? The pattern can be seen from whatever your best fit line or curve is. That's why you put a best fit line or curve in there, okay? Or your trend line or curve. Got all that? All right, anybody have any questions then about how you're going to build a formal graph? So if we go and look at that graph that's already in your folder, in your Google Doc account. All right, well, actually, it's in my Google Doc account, but you have access to it. Okay? And only you have access to yours. Okay, right now. And if a parent asks me, I'll make them a user too. I'll make them be able to see it. Okay? Got it? All right. So, if you go on there and you look at it, I've already made out all this other stuff. Here's what I want you to do with all that other stuff. All this stuff up here. I haven't put the figure label on here. But you have a title, axes labels, grid lines, best fit line, all that stuff is there. Okay? You'll have to do that on your own later. But right now, I'm just asking you to write basically the figure label for the graph and the table label for the table. Okay? But do not walk away from that without taking the opportunity to compare your notes you took today and the notes you took yesterday about what an axis label is, about what a column label is, and what a table label is supposed to be. Compare what I already have on there. Okay, that you're not, for instance, you're not supposed to have any units of measurement in the cells in a table. Remember that? Okay, where do the units of measurement go in a table? Huh? On the column label. In a table, it's the top of the column. Okay? If you notice when you look at the table, the graph doesn't graph everything in that table. It only graphs two columns of data. Those are the key ones. You show all the columns of data so people can see what you're doing. But the columns of data, the only ones that really matter were the amounts of the salt added to 100 milliliters of water and the resulting density. Got that? So make sure you're clear about that. Make sure you get as much meaning out of that as you can. All right? Because you're going to be responsible for this later on. If you decide just to go and write the table label and figure label and forget it, walk away from it, close the book and go home, you're not getting everything out of that you can. And you're going to have to do this on your own. So if you practice a little bit now, invest a little time now, you're going to find some benefits from it later. Any questions about all that?